Well, good evening, everybody. So a few months ago, I went through and put out a video on the EG4 monitoring website regarding the settings of the 6000XP inverter and just kind of went through line by line and explained the settings as I understood them. Well, fast forward several months now, and they have released a secondary settings page, I guess. It's been out there for a while, but I don't think many folks know about it. And they've also gone through and added a handful of new features to the 6000XP, which add some new options to that settings page. So what I want to do is go through those new options that I've found, as well as talk about this other settings page and kind of go through that page as well, just to help explain things again as I see them. And hopefully this will help some folks out, just like the last one did. So let's get started. So we'll start off by going to the monitoring website, which is monitor.eg4electronics.com, and you'll log in. And this is going to be the basic landing page that you end up seeing. So we're going to go to the maintenance page. And when you land on this page, you're going to have to hit the read button for it to pull down all the settings from your inverter. So I'm not going to go through all the settings again on this page, but I kind of want to go through some of the new options that have been added to this original settings page. So if we scroll down to the discharge settings section, we now have several new options here: AC couple and smart load. Now, AC couple and smart load are actually a couple new features that tie into this generator port here on the front of the inverter. So they actually went through and modified the generator controls so that it can do one of three things. It can either be used as a generator for incoming power, it can be used for AC coupling for incoming power, or you can use this as a smart load for outgoing power. But you can only configure one of those three options at a time, but it really gives you more flexibility on this inverter, because smart load and AC coupling have really been almost hybrid inverter features in the past. But now the 6000XP has those features through the use of the generator input port. So actually, if we scroll back up a little bit to the charge settings, you can see here we have the normal generator charge options, and that's kind of what the inverter defaults to, that breaker being used for a generator input. And we can see here all the different generator options, including a new one, generator boost, which, quick explanation for that is, if you're running on generator power and your generator is a smaller generator, say 3,000 watts, but you have a load that needs more than 3,000 watts, if you have this enabled, the inverter will pull additional power over that 3,000 limit from the batteries and merge generator and battery power together. Now that works when you're running on the generator, not when you're running on inverter power. It will not pull extra from the generator. So with the 6000XP defaulting for that port being used as a generator, we have these two options down here, AC couple and smart load. Now, I believe you can only have one of these turned on at a time. If they are both disabled, then it defaults to the generator. If you enable one, that is the option that's going to be used for. I do not believe you can actually enable two of these at the same time, which you can see here. It will not let me enable smart load because AC coupling is enabled. If I disable AC coupling and enable the smart load, then it starts working. So the AC coupling is, and actually I had James explain it to me just to make sure I understood it when I had a live stream with EG4 a few weeks ago. So AC coupling is basically taking grid-tied microinverters that would usually feed power from your solar panels directly into your house and then into the grid. You would feed those directly into your inverter and be able to actually utilize that power for recharging your batteries, for supplying power to your home loads. I think that's all how it works. I'll link to the live stream so that you can go back and listen to him explain it a little bit better than I can. Like all the other areas in the settings, it's defined based on voltage or state of charge. To determine whether you're going to use the state of charge for the battery or the voltage of the battery for these options, it's going to be right here under discharge control. So you can see I have it set to state of charge. But if I switch to voltage, then it grays out all these options on the right for state of charge, and it activates all these options on the left for voltage. So AC couple start state of charge is going to be, when do we want to allow incoming power from a grid-tied PV inverter connected into that generator port? At what state of charge do we want to allow that to come in? So it looks like the default is 50%. And then as our battery starts to get full, when do we want to stop bringing in that extra power from the AC coupled system? And you can see right now it's set to 90%. And again, the voltage is going to be the same thing. At what voltage do we want to start allowing power to come in? And then at what voltage do we want to stop bringing in that extra power from the AC coupled system? So the AC coupling, you can set what seems to be almost any value for your start and your end state of charge. For the AC couple start and stop voltage, it looks like you can really have whatever values you want as long as you don't have the start voltage after the end voltage. A smart load is going to be basically a dynamically controlled switch, to simplify, but you can control that switch based on how much power is coming in from solar or whatever your voltage is of your battery or your state of charge is of your battery. And also, you can control it based on whether or not you have grid power coming into the grid port. So start PV power is, do you want to require a certain amount of PV to come in before the smart port turns on? If you don't want any limitations based on PV, you can set this to 0. Say you want to require having 500 watts of power coming in. So let's say you've got a 500 watt load on that smart port and you want it to basically come from PV. The values for this field are looking for kilowatts. So if I wanted 500 watts, I would do 0.5 for 500 watts and hit set. And that would basically tell this smart load, you have to have at least 500 watts of solar coming in before we turn that smart load on. In my case, I want it to turn on regardless. So we're going to set that to 0. Grid always on. So if this option is enabled, anytime you have grid power connected to the inverter, the smart port will be on. As soon as your grid power goes away, then it starts looking at this start PV power, and then your start voltage or start state of charge, and your end voltage and your end state of charge. So this is actually kind of a nice feature. Let's just say you have an electric car charger, and anytime you have grid connected, you want that charger to be on. If your grid goes out, well, your car charger's not really a critical load, so let's only use it if we have enough power. And so that's where this option would allow you to always use it when the grid is there. But if the grid's not there, then look at my specific specifications to determine if that smart port should be turned on or off. And so we've got the start voltage and end voltage, and start state of charge and end state of charge is going to be very similar to the AC coupling. At what point do we want that switch to turn on and turn off? So the smart load start and the smart load end have to have a 5% state of charge difference. If you try to set anything less than 5% state of charge, you're going to get an error. For the smart load voltages, you have to have a 2-volt difference between the start voltage and the end voltage. So if I tried to put 53 in here as the end voltage and hit set, we get an error. If I set it to 52 and hit set, then it sets successfully. So really the addition of the generator boost option, AC coupling, and smart load option, those are really the big changes that have been added to the original settings page. But if you didn't know this, on the top right-hand corner of the maintenance page, there's this working mode button. And that kind of takes us to me, what seems to be like a new settings page that they're redesigning. So if we click that button, and you can actually switch back and forth. You can see right here again on the top right, old settings page. So that'll take us back. And then we can go to working mode again. You can decide which page you want to be the default page that you land on. So if you want the new settings page or the working mode page to be your default settings page, you can hit this use setting page by default. Hit OK. And now anytime you go to the maintenance page, it's going to by default land you on this page. And you'll see that as we go through some of these different areas, that it ends up really grouping features together better and giving you a more streamlined flow of options on this new page. And so I'm really excited to see that they're working on making these changes and bringing all these together and just making it a little bit easier to understand. So like the other page, we're going to have to hit read to read all the settings from the device. So we've got our device information at the top. We've got our application settings. I want to say on the 18K PV and potentially even the 12K PV, but I don't know this for sure. But I believe there's additional tabs that show up under the application setting next to this basic tab right now. So because this is an off-grid inverter, we have limited features compared to the hybrid inverters, which have advanced grid interactive features. So down here in application settings, we see our EPS output settings, so what's our voltage? 120, 240. What's our frequency? What's our AC input range going to be? Again, all these settings exist on the other page. They're just grouped together differently and displayed differently on this page. These are our basic output settings here. Over here on the right-hand side, they grouped the parallel settings together. And so if you've got multiple 6000 XPs, you would use this area to configure those parallel settings. Now down here on the working mode section, this is probably the section that prompted the new settings page to begin with. That's why it's called working mode when you look at the button from the other settings page. And people tend to get confused as to what are the working modes? Well, you can program your 6000 XP to either charge from the grid, to utilize power from the grid, or to basically use its own power that it creates from solar. And you can schedule when you want your inverter to basically switch modes. So by default, the 6000 XP is going to be in the self-consumption mode. So power is going to come in from PV. It's going to go to the loads. If you have excess PV, it's going to go to the battery. If you don't have enough PV, power is going to come from the battery. And that's just how it's going to work all day long. And so you can see self-consumption, it gives you like a timeline of what mode your inverter is in at any point in time during the day. So you can see the green, self-consumption, from midnight to midnight. Let's just say that grid power is cheaper overnight. And so we want to charge from grid overnight while using PV and the battery during the day. So we can go to this AC charge option here, which then populates parameters underneath for when we want to AC charge. So AC charge based on, do you want to do it by time? Do you want to do it by voltage, by state of charge, by battery voltage and time, by battery state of charge and time? Lots of different options. Again, all of this was available on the other settings page, but it was broken up into different areas, and it was kind of confusing to not have them grouped together, which is why they have this working mode section. So let's just say based on time, and we'll save that. And we want to charge with 30 amps. That's fine. So let's say from midnight to 6 a.m. we want to charge from the grid. And so now you can see on here, from midnight to 6 a.m., it's going to charge solely based on time. And if I wanted to change it to be, just based on the state of charge, you can do that from here. If you wanted to say, only if I'm under 80% state of charge and between these values, so we could say, if I'm under 80% and I'm within this time range of midnight to 6 a.m., charge my battery and stop charging till when it gets to 100%. So you've got a lot of different options under here that you can determine when you're going to charge. And then on the right, you can set your time frame. Let's just go based off an example time frame from someone who has free power overnight. So let's say that it goes from 8 o'clock at night until 7 o'clock in the morning. I think you can set these at different times. So if we said 8 o'clock to midnight and hit set, and then it goes through to the next day, and so we say from midnight to 7 a.m. So now, from 8 p.m. through till 7 a.m. the next day, we're going to charge 30 amps from the grid. And so that's AC charging. They give you 3 different time slots that you can program in different times for AC charging. So let's keep going with this free power overnight aspect, but let's look at maybe in the afternoons when everybody's getting home from work, your electric power cost doubles. I know we have higher rates during the summertime between 2 p.m. and 7 p.m. So let's go with that 2 p.m. and 7 p.m. idea. And let's say from noon to 2 p.m., I want to make sure that all my solar power is going directly into the battery bank. So I have a full battery bank before that higher rate kicks in. So I can switch over to AC first mode so that the inverter basically powers all its loads through the grid connection, but it's not charging from the grid. So we'll say 12 in the afternoon until 2 p.m. So now we have our 8 p.m. to 7 a.m. where it's going to try and charge the batteries. We have 7 to noon where it's going to be in self-consumption mode. It's going to use whatever PV comes in, and it's going to take power from the battery. From 2 o'clock until 4 o'clock, all my loads are going to switch over to the grid so that PV can recharge those batteries. And then from 2 o'clock to 8 o'clock, it's going to utilize battery power and PV power to supply power to the loads. I hope I'm making sense with this. I don't feel like I'm really explaining it clear enough, but I'm hoping that even just the picture of showing you the options kind of helps understand how it works. So each of these, AC charge and AC first mode, you can set up to 3 different time frames, and then everything else is automatically going to be self-consumption. So if you click self-consumption down below, you notice all the options go away, and that's because by default, anything that is not assigned a time, the inverter will be in self-consumption mode. So again, I hope I'm not confusing you even more. I hope I'm actually helping explain that. And if I'm not, please drop in the comments below. Maybe I can help clarify it a little bit more. But that's the working mode settings. If we scroll down further, we can see battery settings, and now we can see that they're starting to add slider options in for making value selections. So you can see your maximum and your minimum values right here. And so you can see they've got this for the charging section, and even over here on the right, discharging. They started adding switches instead of drop downs, trying to simplify the selection. And so they're doing a really good job here. They've got some options down here for double sliders for a start and a stop. So you can easily look and see, what's my start and stop cutoff stated charge? And again, these settings are already existed in the old settings page. They're just redoing how the interface looks. We get down here, the generator function. Since these 3 options all relate to that generator terminal on the inverter, they've grouped them together under this generator function section. Now, at the moment, smart loads are not configurable under this new page. AC coupling is, and generator is. And just remember that if you don't enable either of these options, generator is going to be enabled by default. And you can see your different options, the different selections here, and then they've got their fan settings down at the bottom. So there's a couple of things that are only existing right now on the old page, but most of the options can be handled from this new page. Any change you make on this page will reflect back on the old settings page. So you really just kind of have to determine which page works better for what you're trying to do. For me, this new settings page just helps group things together better. This is the one that I tend to use more of. It's easier to understand than just a lot of listed fields. They do a good job of grouping things together. So again, I really hope that with some of those working mode options, I didn't confuse you any more than you may already be. I really hope that I actually helped explain that a little bit, at least from my understanding. Again, like the other video, if I don't understand and I'm explaining some of these options wrong, and you know the correct way that they need to be explained, please let me know so that we can get that information out there and share it with everybody else. I know there's been a handful of people that I've talked to that didn't even know that this new settings page even existed. So I've wanted to go through and do this video for a long time, and everything else just kind of gets shuffled in front. But some time actually opened up for me, and I thought, I got to do this now before something else fills that slot. So again, take a look at it for yourself. If you've got questions, if you've got comments, please leave them down below. I'll be happy to try and explain if I can, and if I don't know the answer, I will try to find out what it is. I know there's a lot of folks that use these systems even more than I do, that I'm sure they might have more answers than I do. I do want to go through at some point and do a quick video on how you can utilize 120 volts for your input. I know I did it in the live stream video several weeks ago, and I went back myself and watched and realized that my audio was horrible. And nobody said anything. At least not that I remember seeing in the comments. So I want to go back through and kind of redo that and re-explain that, just so that, again, I can get the information out there and help those regarding that. But I got to try and find time to throw those two videos together and put those out there as well. So again, hopefully this helps. And with that, I'm going to let y'all go. Y'all stay safe, stay warm, and we'll catch up with you later.